Hello, everybody. My name is Zachary Molinero, and today I'm presenting programming assignment 5. And in this assignment, I'm exploring how the number of memory frames affects page replacement performance. And I'm going to use AI to help me understand the concept and then show it in my C program that I made for the assignment. So first and foremost, let's start with the AI prompt. Okay, let's try that again. That clearly didn't work. Let me probably refresh the page, maybe. Into a new chat, refresh, ask again. There we go. Very strange. Okay. Okay. So, the concept we're talking about is number of memory frames affects page replacement performance. And pretty much what the AI is saying is how it works. So with the fewer the memory frames, the operating system has to remove pages more frequently to make rooms for the new ones. If a program later needs one of the removed pages, a page fault occurred and the page must be loaded back into memory. With more memory frames, more of the program's pages can remain in memory simultaneously since the program need since the pages the program needs are more likely to already be in the memory, page faults occur less. So you actually want to have a good amount of memory frames so that you get less and less page faults. So pretty much a page fault is just what happens when the program needs something from memory that isn't loaded, so it's not in its memory. Um, for people confused with frame, a frame is basically a slot in memory that can hold one page. More frames means more slots available. So take that. Pretty much frames are your slots. Think of it like RAM in a sense. Um, More frames is fewer page faults, which we just talked about. Um, But there are diminishing returns because if you, let me see if it talks about it here. Yeah, here we go. Increasing the number of frames can unexpectedly increase the number of page faults for certain reference strings, such as more advanced algorithms. Well, more advanced algorithms don't have this problem. That's right. So adding more frames never increases the thing. But let me see. I have it on my notes here. Yep. After a certain point, adding more frames barely helps because you're already holding almost everything you actually need. So at some point, you're just increasing your memory slots for the sake of increasing your slots. Like there's nothing really to it because you already have what you need. Now, let me pull up my program. Perfect. Here we are. Okay, drop this down so you guys can see. Okay. So now let me Okay, so we'll do FIFO and LRU now. And let me see if I can find this. Yeah. Okay. So the main thing I want to talk about here, besides the fact that this is let me just actually scroll through this first so you guys can see my programming assignment. I'm going to run it in a second here. Okay, and then there's one variable I want to talk about here. If I can, here we go, num frames. So this one variable controls how many slots memory has to work with. It's the thing that we just talked about, which is your slots and your frames. So now what I'm going to do is run the code and we're going to see what happens. Perfect. Okay. So now Okay, so we have page faults, the final state of memory, and page faults. Let's start with page faults. So in FIFO, we have 15 page faults, and in LRU, we have 12 page faults. So, first of all, the fault count that we have is how many times the program had to go fetch a page. The final memory line just shows what pages were still sitting in the frames at the very end. So that means FIFO had to do this 15 times and LRU had to do this 12 times. And then this is the last state of their memory after everything is said and done using the text file that I have here, which is where we're hypothetically pulling our pages and numbers from. It's just in this text file. Let me see if there's anything else. No. Now we're going to move on to the upgrade part. Oh, one thing I did forget to mention is why this matters in the sense. So this is important because in a real operating system, let's say that we weren't making this program and simulating all this. If it wasn't a real operating system, you're not just managing memory for one program. You're splitting frames across dozens of running processes, and if you give one process too few frames, and it will fault constantly, which slows everything down. That's called thrashing, which is somewhere in the lecture. Um, Essentially, in a real operating system, there's so many other things running at the same time that if one thing starts to lag behind, the whole system starts to lag behind. And now let's move on to the AI upgrade. Okay. Okay, perfect. So, pretty much what it's asking is, what the upgrade is instead of running the simulation once with one frame count, um, it's just gonna wrap it up in a loop that runs again and again with a different frame count each time, and then it's gonna print its results like this in a table format. Yeah, see print table header and all that. So, right now what I'm gonna do is I'm gonna go ahead and start getting this all over. Give me 1 second. This shouldn't take too long. Give me 1 second here. See if I'm missing anything here. No, I think we're good. Okay, real quick. Okay, now we're gonna go to, oh, let me real quick let me swap the share screen before I explain this. There we go. Okay, I'm looking for this right here. One multi-frame comparison. Okay, so pretty much this function just counts from 2 up to 6, and for each number, it returns the exact same FIFO and LRU functions from before. Nothing about the algorithm changes. I'm actually just calling it more than once so that we have different frame comparisons. You can see that I ran it already to test it. Don't worry about that. We're going to talk about that. Actually, we're going to talk about that right now. So let's talk about this specifically, the table, which is the multi-frame comparison, which counts each frame and then tells me how many faults are happening in each frame. So you can kind of see the pattern here, going from 2 to 6 frames. FIFO drops from 15 down to 6, while LIU drops from 17 down to 6. More slots and more slots, fewer faults, exactly kind of like the AI explained earlier. The more slots you have, the less amount of faults you're going to have. Um, the one interesting thing that you can see here is that FIFO actually did better in the beginning, but then it stayed the exact same at the next frame while LRU automatically went down. And then it kind of, again, like I mentioned earlier, you start getting diminishing returns because then LRU is still better, LRU is still better, and then LRU and FIFO are at the exact same. So it kind of um, doesn't really matter towards the end there. Um, So pretty much, another thing that you can take away from this table is that uh, these two algorithms don't always behave the same way that you think they are. It just depends on the specific pattern of pages being accessed. So this could be completely different for someone else's programming assignment compared to my programming assignment. And just to kind of wrap it up here, so more frames not genuinely, generally mean fewer page faults. But with diminishing returns, as you can see, um, more memory in the beginning gives fewer faults, while less gives more. And then it slowly gets more diminished as we go along with how many slots that we have. So that's the real trade-off of operating systems deals with when splitting memory across the processes. So, if there's any questions or anything that you would like to comment or talk about, please let me know. That was my program for programming assignment 5. Well, that was both my program and then my upgrade to my program. So take it as that. And yeah, thank you for watching and have a phenomenal day.